Assalamualaikum. My name is Ahmad Hanis Haikal bin Ahmad Nazri. My matrix number is B0520101140. Today I will explain about question 1. Figure 1 shows the ball is released from rest, which labeled as A, and slides down along the smooth ramp to the end. The end of the ramp labeled as B. The height of the ramp is 3.5 meter. The angle of slope of the ramp is 35 degree, while y0 is 1.5 meter. Y0 can be obtained from assignment part 1. For question 1A, you can see a sketching of free body diagram. We use a ball, so that's why the free body diagram is in a circle. From the diagram, you can see the weight, which is pointed downward, while force N pointed upward. The force F is located at the left side to indicate the 35 degree slope. For question 1B, the question asks to calculate the speed of the object just before it leaves the surface at B, also known as VB. For this question, the formula of conservation of energy can be used. The formula is TA plus summation of U A to B equal to TG. TA represents 1/2 mv square, while summation of U A to B represent mgh, and the last one is TG, represent 1/2 mv square. M, which is the mass of the object, is 0.4. VA is 0 because it starts from the initial, so the object is static. G is gravitational force, which is 9.81, and the height of A is 3.5, while the height of B is 1.5. Rearrange and we will get the speed of the object at B, also known as VB. Okay, that's all. For question 1C, the question asks to calculate the distance from the wall of the ramp at B to where the object strikes the ground. For this question, the formula of kinematics has been used. The formula can be divided into two parts, which are horizontal motion and the other one is vertical motions. For horizontal motion, the formula used is SB equal to S0 plus V0 SB times T. S0 is equal to 0 and V0 SB can be obtained from question 1B. So, rearrange, we will get equation 1. So, for vertical motion, the formula used is Y equal to Y0 plus V0 YB times T minus 1/2 GT square. Y0 is 1.5 meter, while Y0 YB is 0, and G is gravitational force is 9.81. So rearrange, we will get equation 2. So the last step is you substitute equation 2 into question 1 and you will get 3.56 meter. So that's all. For question 1D, the question asks to compute the speed at which the object hits the ground. This question uses the same formula as question 1B, which is the formula of conservation of energy. The only difference is we use the height of A, which is 3.5 meter. So the velocity that we get when the object hits the ground is 8.29 meter per second. That's all.
Okay, for question 2, the question is the object from part 1 released from rest and slide down along the smooth ramp as shown in figure 2. This is figure 2. And question A asks us to calculate the velocity of the object just after it rebounds on the ground. So for this question we use 4 steps. First step, we use kinematic equation and we consider that the ball is falling in vertical motion. This is the formula. Vgy square equal to v1y square plus 2ac bracket sgy minus s1y. And we substitute the value into the equation and we get vgy square equal to 0 since the object released from rest, so v initial is equal to 0 plus 2ac. ac we use gravitational acceleration multiplied by sgy, which is 0 because it is on the ground, minus 1.5 meter s1y height before it rebound to the ground. So this is height for s1y and this is for sgy. We settle it down and we get vgy square equal to 29.43, and then we set this value and we get the final vgy equal to negative 5.425 meter per second, and the motion is downward. Second step, we apply coefficient of restitution in y direction to determine vgy2. The equation used is E equal to vg2 minus vgy2 divided by vgy1 minus vg1. This one. And we have E from the question given 0.7. Then we substitute the value we have in this equation. So vg2 is 0 minus vgy2 is unknown divided by vgy1 that we find in first step, negative 5.425 minus vg1 is 0. E, we substitute 0.7. Then we rearrange the equation and we get negative vgy2 equal to 0.7 multiplied by negative 5.425, and the final answer we get is vgy2 equal to 3.80 meter per second. Moving on to step 3, we use conservation of linear momentum in x direction to determine vgx. The equation is m v1x equal to m vgx. Since m have same value, so we can remove it and we have v1x equal to vgx. Okay, since v1x is equal to 6.26 from here, so that vgx also 6.26 meter per second. For the last step, we find rebounding velocity by using magnitude and direction. The magnitude for vg2 is 6.26i plus 3.80j meter per second, and the direction vg2 equal to 6.26 square plus 3.80 square, and the final we get is 7.32 meter per second. Question B asks us to compute the maximum height to which the object raises after the first bounce. First bounce is here, okay, the first bounce here. Okay, for this question we use kinematic equation to find h. So the equation is vgy1 square equal to vgy2 square plus 2ac bracket s2y minus sgy. And we substitute the value into the formula. Vgy square 1 is 0 equal to vgy2 is 3.80 square plus 2, and ac we use gravitational acceleration negative 9.81 multiplied with s2y is unknown and sgy is 0. So we get 0 equal to 14.44 minus 19.62h, and we rearrange and make h as subject, and we get the final answer is h equal to 0.74 meter. So that's all for question 2. Thank you.